Okay, so just like we were talking about on Friday, this whole idea of Moletown, right? That was kind of where we stayed last week. And so in Moletown, basically, if we start in Moletown, so we have something in moles, we have to cross the bridge, right? Anytime you visit Moletown, that is like the go-to place, right? And so when we cross that bridge, that's where we're actually forming that mole ratio, which is coming from coefficients, the big numbers in the front of the different chemical formulas in a balanced equation, right? So the big idea was that we start somewhere, we cross the bridge, and we were stopping. So we were starting and ending in Moletown. Well, today we're going to go ahead and bring in Grahamland. So we're going to talk about what some people call the two-step, right, where we are basically traveling from Moletown to Grahamland, okay, after crossing the bridge. So in Moletown, the minute you are in Moletown, you are crossing that bridge, no matter what. It has to be in that calculation. Or we can start in Grahamland, travel to Moletown, and then cross the bridge. So you kind of notice that it's going to be either at the beginning or at the end of some sort of our stoichiometry calculation. So when we're dealing with that, let's go ahead and put gram to mole or mole to gram. That is our goal today, okay? Like I said, two-steppers. So usually the way this is set up is we will usually have our railroad tracks like so, and you're going to end up having obviously what's still given to you in the problem up here. We're still going to bring our words down to the right. We're going to do it again, okay? And somewhere in here, you're going to have a mole bridge. So you're either going to have that mole bridge here, or you're going to have it at the very end. So notice these setups are very, very similar still, right? So no matter what, we're bringing words down to the right, but you might have the mole bridge as the second step, or you might have it as that last one. And it'll depend on who you're starting with in this first box, right? So just another quick reminder of one thing that we pointed out last week was that as you're kind of reading your question, you want to get in the habit of underlining what you're given and circling what your goal is or what you're solving for. Okay, so we're going to see, I'm going to use that method on this next slide for to show you guys a couple examples. All right, so looking at our question, we have how many grams of NaOH are needed to react with 6.5 moles of aluminum nitrate. All right, and so looking at our balanced equation, yay, it's not balanced. So we got to actually do that real quick. So looking here, I'm going to go ahead and start the balancing process. I'm going to use the line down the middle method. What I want to point out here is that we have nitrate, NO3, and we have hydroxide, OH. So I'm going to actually leave those together since we see that they show up on both sides of this chemical equation. So I'm going to have aluminum. I'm going to have that nitrate. I'm going to have an Na, sodium, and I'm going to have OH, okay? So leave your polyatomics together, and that way you don't have to worry about splitting those up into oxygens and things like that. That gets a little messy. All right, so now that we have that, let's go ahead and do our little count up. So on this side for aluminum, I have 1. On my product side, I also have 1. On my reactant side, I have 3 nitrates, and on my product side, I only have 1. On my reactant side, I have 1 sodium. On my product side, I also have 1 sodium. And then on my reactant side, I have 1 hydroxide. Product side, I have 3. So hopefully you're kind of already seeing that we're going to be able to fix this pretty simply, I think. So looking here, I'm going to go ahead and fix this nitrate thing. All right, so I see that I have 3 over here, but I only have 1 on this side. So I'm going to go ahead and add in a 3 in front of this last one. We're going to recount. So now I have 3 sodiums and 3 nitrates. Go back to this side. I notice that now my sodium is in balance, so I'm going to go ahead and add in a 3 in front of the sodium hydroxide. Do a quick recount. I now have 3 of my sodium and 3 of my hydroxide. Everything is balanced. So we have a 1 to 3 to 1 to 3 mole ratio. All right, so our mole ratio could be written like this. Okay, all right, so moving on, let's get into the stoichiometry part. So I have, here we go. All right, so if I have my, how many grams of NaOH? So I'm going to go ahead and circle what my goal is, grams of NaOH are needed to react with, and this is my given, 6.5 moles of aluminum nitrate, okay? So just like usual, we're going to grab what's given to us in the problem, and that's going to be going into our first box. So let me go ahead and get my railroad track set up, okay? I'm going to take what was given to me in the problem. We're going to start with there. So 6.5 moles of AlNO3 little 3. Okay, I'm going to make my little line down the middle. Okay, so next step, we're going to take our words. We're going to take those down to the right. Okay, so actually I'll leave them the same color. So we have mole of AlNO3 little 3, so aluminum nitrate. Okay. So I want to point out where we are on our map, all right? Okay, so according to our map, we started in moles. So we were in Mole Town. So the first thing that we have to do is automatically cross that bridge, right? So we're going to go ahead and go right into, that's going to be the step with our mole ratio. So like I said on the previous slide, that it's going to depend on where we start, right? Where that mole ratio is going to be. So what we just found out is that if we start with moles, then the next step is the mole ratio. If we're starting with grams, then the second step is going to be that mole ratio, okay? But don't sit there and like focus on trying to memorize that. Pay attention, bring your words down to the right. If you have moles on the bottom, that's when you cross that bridge, right? So the minute that you see that mole ends up here, we have to cross the bridge. You have nowhere else to go, all right? All right, so now that we have that figured out, we're going to be crossing the bridge on this step. So we're going to go ahead and be saying what we're changing into. So our goal is NaOH. So I'm going to go ahead and put mole NaOH up top. And actually, I meant to do that in another color so that we can see that break where we are actually changing characters here. Okay? All right, so we have moles of NaOH on top. So right here, we know that in this mole ratio, we're going to be looking for those coefficients, right? So coming to the balanced equation, I have AlNO3, so this is a 1. So we're going to put a 1 down here because we're taking it from our balanced equation up here, right? And then we have NaOH, we have a 3. So we're going to go ahead and put in the 3. Okay, we're moving on to our next little step. So we have not gotten where we need to be. We're still in Mole Town, right? So we've now crossed the bridge. We are going to travel to Gramland. Now remember, when we're traveling to Gramland, that's when we're going to be using the molar mass from our periodic table, okay? So we're going to take the words down to the right, just like before. Once we have moles of NaOH down here, okay, we're going to be converting into grams of NaOH up here. Okay, now the minute that we have moles and grams together, you're not using that coefficient anymore. This is a conversion. So this is where you are guaranteed a 1 at the bottom and a molar mass on top, no matter what. Okay, so we always have that 1 mole that we're defining, and then molar mass comes up here. Now, we got to figure out our molar mass of NaOH, so we're going to take care of that real fast. I have here my periodic table. Na is over here. We have 22.990. So I have 22.990 plus oxygen, which is 15.999, and hydrogen, 1.008. We're going to add all those together into the calculator. Push enter, and we got 39.997. Okay, so now we're ready to figure out our answer. So we're going to go ahead and pull that calculator back up. So once again, what we did was we started in Mole Town. We crossed that bridge using our coefficients. Then we traveled to Gramland by using our molar mass, where we have 1 mole is equal to the molar mass of any compound. All right, so now we're ready to multiply all the way across. So we're going to handle the whole top row. So we're going to say 6.5 times 3, so now I'm right here, times 39.997, so now I'm right here. I'm going to go ahead and push enter. So I've handled the whole top row. Then I'm going to divide by 1, divide by 1. So I want you to note that I am pushing divide over and over. Do not push equals in the middle of all this. I mean, you could, but I think it's easier to just kind of see everything all together. And so you push divide, divide. Now, did we have to divide by 1? No, not really, but we're still going to get ourselves into that habit. So the final answer is 779.9415. I'm going to write that out, and then we'll figure out Sig Figs. So 779.9415. This is grams. So what we're going to refer to for Sig Figs is up here. We see that our initial question only had 2 significant figures. Lots of multiplying and dividing going on, so we have to pick our least number of significant figures here. So we're going to go ahead and go, here's 1. Here's our next one. So there's our second one. We're going to check that one. We're going to handle it, and this is going to now change into 780, no decimal, and that allows it to be 2 significant figures. Now, if you are forgetting about Sig Figs or when in doubt, you can, sometimes your teacher is going to tell you how many decimal places to round to, so pay attention to that, okay? So the other way that we could have done this is 779 and gone to the first decimal point up here, 779.9 grams. Okay, so either one of those 2 answers is good. This one is following the 2 significant figures. Okay, so for this next one, let's go ahead and see what we're dealing with here. So it says, how many moles of zinc 2 chloride, or zinc chloride, will be produced if you react 450 grams of HCl? So I've kind of already laid out what's going to obviously go into that first box, and then we're going to be searching for moles. So when we're looking at our map, looking at the map, we basically are starting now in gram land. We're going to convert to moles using our molar mass. We're going to convert to moles, paying attention to where our units are going, down to the right? And then once we're converted to moles, so we have moles on top, the next step is to do that mole bridge, all right, or that mole ratio. So back to the first slide that I was showing you, we are now starting with moles. So that means that our second step, we're starting with grams, so that means that our third step is that mole to mole ratio, okay? So let's go ahead and take a look at this balanced equation, which is not balanced again. So this one shouldn't take us too long. It's not as bad as the last one. So we have zinc, we have hydrogen, we have chlorine, okay? So on this side I have a 1, this side I have a 1. For hydrogen, I have 1 on my reactant side, 2 on my product side. And on my reactant side, I have 1 chlorine. Product side, I have 2 chlorine. So we see that this is going to be the issue. So what we're going to do is we're going to throw a nice big 2 right there. We're going to recount, and now we are all balanced. So this is going to be a 1 to 2 to 1 to 1 ratio. All right, so let's go ahead and start diving into the stoichiometry part. So I'm going to start with that 450 grams of HCl. Okay, I'm going to bring those words down to the right. And then let's see where we're at. So we've knocked out the first step, put what we have in the problem into that first box, brought our words down to the right so that we can pay attention to what goes next. So looking here, we know that we're in a conversion. So we have to convert to moles. So we are not changing characters or anything yet. We are still talking about hydrochloric or hydrogen chloride, okay? Usually it's hydrochloric acid. All right, so we have that. All right, so what we're going to be putting in here, since it's a conversion, is always a 1, right? These two things go together. And this is going to be the molar mass. So this is like one of your options that you're always going to have in a stoichiometry thing when we're dealing with grams. We have to have the molar mass. We have to convert to moles or back, right? So molar mass is going to go here. So we're going to go ahead and pull up our periodic table. We are going to add together 1 hydrogen, which is 1.008, plus a chlorine, which is going to be 35.453. Push enter. I have 36.461. So I'm going to go ahead and put 36.461. Okay? All right. So now we're going to take our words right here. Okay? We're going to bring that down to the right because we're not where we want to be yet. We want to be in moles of zinc chloride. Okay? So we're going to bring our words down to the right. So I have my moles of HCl right here. Okay. And we're now traveled to Moletown. What's the first thing you got to do when you get to Moletown? We got to cross that bridge. So we're going to cross our bridge to change characters. So we're going to go from moles of HCl, this is our mole ratio, moles of HCl to moles of zinc chloride. This is where our coefficients are going to go. So HCl has a 2 in front of it, and then the coefficient on zinc chloride is a 1. So we're going to go ahead and now start typing that into our calculator. We're going to go all the way across the top. So I have 450 times 1, so I'm right here, times 1 again, push enter. I have 450 for the top line. Now I'm going to divide by each of these at the bottom. So I'm going to push divide by 36.461. I'm going to divide by 2. I'm going to push enter. Now I got my answer, which was 6.1709. Let's go up and check our significant figures. So here I have all trailing zeros with a decimal count. So this is actually 4 significant figures that we're looking for. So we're going to go 1, 2, 3, 4, and check the one behind it. So our answer is going to be 6.171 moles of zinc chloride. Now, again, if you're not doing the Sig Figs, pay attention to whatever your teacher is asking you to round it to. If they say the second decimal place and you underline that second decimal place, you check the guy behind it. Okay, so make sure you're paying attention to that. All right, so just as a recap, what we're doing, okay, is if we start with grams, okay, just remember that we are going to be having grams of A. We're going to bring our words down to the right and be changing into moles. We're basically traveling to Moletown. Remember the way that we do that, we always have a 1 and we always have the molar mass. Okay? Once we're there, we're going to take those words down to the right. And then this is where you would actually change characters. Moles of B, we're in Moletown, we're crossing that bridge using that mole ratio. That is where your coefficients from your balanced equation go. So this is a conversion, so convert, and then we cross the bridge. All right. The other option or the other type that we just saw was that if moles were given, okay, we have moles of A, and that just represents a compound. We would bring those words down to the right. We notice that we already have moles ready to go, so this is we're already in Moletown. We're using that information that we know that we're crossing the bridge, or using our mole ratio. That's where our coefficients come from. Okay, so we're going to go from moles of A, we're going to change right into moles of B. Those words come down to the right. And then we're going to convert into grams of B. So this is a convert step. Remember, your conversion is always a 1, no matter what, and this is a molar mass. Okay? Don't forget, you are multiplying across the top and divide, divide. Multiply across the top, divide, divide, and that's how you're going to get your answer.